Hi, this is Adrian from Live to Learn Academy, and today we're going to be going through lesson 8.2, transformations of logarithmic functions. So guys, transformations of logarithmic functions, we are using this universal equation, okay? And I want you guys to copy this equation down because you are going to need this on a test. So if you have a time to screenshot this video, screenshot the video, copy this down. This is a great a hack for you guys. So you're going to have negative k x minus d plus c. Now this is the universal transformation equation, okay? But this is all useless information unless we know what each of these variables mean. So if you see over here, the negative here represents a reflect over the x-axis. The negative here represents a reflect over the y-axis. The a represents a vertical stretch when a is greater than 1, and a vertical compression when a is between 0 and 1. The k represents a horizontal compression when k is greater than 1, and a horizontal stretch when k is between 0 and 1 by a factor of 1 over k. Now, a lot of this, guys, might be review for you because it's the same kind of universal equation we're seeing in trig functions, in quadratic functions, in polynomial functions. We are seeing the same kind of universal equation play out. So this is very, very important for the course advanced functions. Okay, let's look at D. D represents a horizontal translation. Now, the thing with D is that positive actually means to the left and negative actually means to the right. So notice how this is like the opposite. You would think that positive meant to the right and negative meant to the left, but it's actually the opposite for horizontal translations. But for C, the vertical translation, positive is up and negative is down. And this makes sense. So why am I telling you this? Oh, there's another one I forgot. B, which it doesn't really enhance the transformations, but B is just the base of the logarithmic function. So it could be base 10, it could be base 2, 3, 4, it could be base 100. It does not matter. This is the base. The base does not affect the transformations, okay? So I'm just going to put this as a star here so you know that it does not affect the transformations. Just highlight this over here. Okay, so why do we need to know this transformation? Because the whole point of understanding this transformation is to lead us into our second concept, which is the mapping rule. And this is also review. The mapping rule is x over k plus d ay plus c. Now remember, d over here, it's always going to be the opposite sign for d, okay? Okay, so why do we need to know this universal equation and the mapping rule? The reason why is because we need to use a, k, d, and c from our universal equation, and we're going to get those values so we can plug it in to our mapping rule. Once we know the mapping rule, you can kind of think of this as a generator, okay? So it's kind of like a piece of code. You could think of it like a piece of code. And the generator is pretty much used to take an original parent function, that's a logarithmic equation, put the points into the generator, and it's going to spit out the transform function. So let's look at the example of the parent function y equals log 2x. So let's say this is the parent function, okay? The first thing we need to get when it comes to the parent function is some points. We need some main points. Now, if you watch my video on in 8.1, I gave you guys two main points. The first point is 0, 1, right? Or 1, 0. If we make x equals 1, we get 1 and the y value would be 0 because any log times 1 will give us 0. The other point we can get is 2. If I say log 2, then I would get log 2 base 2, which just equals 1. So that would give me the y value of 1. The other point I can also get is log 2 squared. And the reason I did this is because I can bring this 2 to the front, so I get 2 log 2, 2, which is just 2 times 1, which is just 2. So here, if I make my x 4, which is 2 squared, I'll actually get my y value to be 2. Okay? Now the reason I did this is because I wanted to get 3 points to start us off with log 2x. And the whole point of this exercise is to take these points, these main points from the parent function, we're going to plug them into our generator, and then our generator is going to spit out 3 new points for our transform function. So what are these new points going to look like? This is going to be the new point of x, and the new point of y. But where do we get these points? When we plug these x values right here, this x and y value as x and y over here, we actually get the new x and the new y. And we're doing that with each of these 3 points. So 1, 0 will get us a new x and a new y. 2, 1 will get us a new x and a new y. And 4, 2 will get us a new x and a new y. And those will all be a part of the transformed function. So these are all going to be a part of the transform function. So the purpose of this lesson, guys, is to really understand, okay, what is the universal equation? And from this universal equation, how can I determine the mapping rule by finding out what a, k, d, and c are? The only way I'm going to know what a, k, d, and c are is when I look at the template of this universal equation, and then I can depict what a, k, d, and c are. Once I have the mapping rule, this is all useless until I use the mapping rule as a generator to get the transform function. So I would take the parent function, take 3 points from the parent function, plug them into my generator, and then spit out 3 new points for the transform function. Once I get the 3 new points from the transform function, I'm just going to plot and connect the dots. And that is essentially the concept of how we do transformations in logarithmic functions. Now, one thing I want you guys to know are some key findings. And these are some things that I really want you guys to know when it comes to logarithmic functions. When you have the universal equation, the thing is, in a logarithmic function, we always have a vertical asymptote in the log function, right? So the variable that is going to affect or shift the vertical asymptote is going to be this d variable. The horizontal translation will shift the vertical asymptote, okay? So if the horizontal translation is positive, it'll shift it to the left. If it's negative, it'll shift it to the right. And the reason I'm telling you guys this is because it's one thing to just plot these new points and connect the dots. But remember, in logarithmic functions, we also have a vertical asymptote, right? Sometimes with the base function, it's going to be x equals 0, as we know from the previous lesson. But as we move this left or right, that's going to affect the vertical asymptote. So that d value is very, very important in being able to plot the logarithmic function on the graph. Okay, so there you have it. If you guys found this video helpful for breaking down the concept of transformations of logarithmic functions, feel free to drop a like on this video. If you're someone who needs tutoring and you want to go through more practice problems, feel free to click the link in our description and our team would love to get in touch with you to help you with this course. But without further ado, I'll see you guys in the next video.